In this demonstration, I'll show you how to manually solve a linear system with 3 variables without the usage of matrices and without the usage of technology. Solve the following. We have a linear system with 3 unknowns, and our strategy here to solve this manually is to reduce a given system of 3 equations containing 3 unknowns to a system of 2 equations with 2 unknowns which we already know how to solve. And the way we do it is we take any 2 of these 3 equations, and by using either addition, subtraction, or substitution, we eliminate one of the variables containing a single equation in 2 unknowns. So what we'll do first is we'll pick 2 of these equations and then another 2 equations, and we will eliminate the same letter twice. And what we'll have is a linear system of 2 unknowns. Let me show you what I mean. Let's get started. Let's start off by trying to eliminate y from these 2 equations. So the way we do that is, first of all, we'll write them out again, like so. And since we've decided to eliminate y, what we have to do is multiply this whole equation by 7 and this whole equation by 4, which will ensure that they become the same coefficient. So let's multiply this by 7 and this by 4. And we end up with the following. 6 times 7 is 42x. Negative 4 times 7 is equal to negative 28y. And negative 7 times 7 is equal to 49z. 17 times 7 is equal to 119. 9 times 4 is 36. 28y. 16 times 4 is equal to 64. And 29 times 4 is equal to 116. Wonderful. So what we'll do next is bring this over down here. My mistake. Let's try that again. We'll bring this over here, and what we will try to do now is eliminate the y. And the way we do that is we will add the 2 equations together. Sorry, subtract them together. Well, the reason why I changed my thought is because I asked myself, what do I need to do to make the 2 28s to 0? If we chose subtraction, it becomes addition, and that eliminates it. So we'll subtract them. That will eliminate the middle term here. And we end up with 6x and negative 49 minus 64. Negative 49 minus negative 64 is equal to 15. That's positive 15. Z. And these 2 subtracted is equal to 3. So, as you can tell, we have produced an equation with 2 unknowns, and we're going to need to do this again using 2 other equations. So, let's pick this one and try to once again eliminate the y. What we will do is write it out. I'm just going to erase this to create more room. And we will delete this. (6x minus 4y minus 7z is equal to 17. 10x minus 5y minus 3z is equal to 23. We'll multiply this whole thing by 5 and multiply this whole thing by 4. That will ensure that the y's are the same. 30x minus 20y minus 35z, and 17 times 5 is equal to 85. Next, 40x minus 20y minus 12z, and 23 times 4 is equal to 92. How do we get rid of these y's? Well, we're going to need to subtract the two equations, and we end up with negative 10x. These two are eliminated successfully. Negative 35 minus negative 12. Negative 35 minus negative 12 is equal to negative 23z, and these two subtracted is equal to minus 7. So we have two equations here which we can use to solve for both x and z. Let's write them out. 6x plus 15z is equal to 3. And notice that they're both in standard form, where the letters are on one side and the constant is on the other side. That's another good thing. Great. Now we have to decide which of these two variables we want to eliminate. And we're going to eliminate the x's. It's a choice that I made because the numbers are smaller than 15 and 23. And what I'll do is multiply this whole thing by 10 and this whole thing by 6. If we do that, we end up with 10x plus 150z is equal to 30. And at the bottom we end up with, that should be a 60, negative 60x, 23 times 6 is equal to negative 138z, and these two multiplied is equal to negative 42. Which operation should I use to eliminate the x's? If you chose plus, you are correct. The x's are gone. These two added up is equal to 12z. These two added up is equal to negative 12. And if we solve for z, we end up with negative 1. So we found our z value. We now can find our x value. And we can use either this formula or this formula. Either one will do. I'll use this one for the sake of simplicity. 6x plus 15 times negative 1 is equal to 3. That is equal to negative 15. We bring that 15 over and we get 18. And if we solve for x, we end up with 3. So far, our x coordinate is 3, our z coordinate is negative 1. To find your last coordinate y, you can use any one of these equations here. So let's rewrite these out. We have 3, a missing y, and negative 1. We will now substitute these values in here. I'm just going to create some extra room for you. You can choose any one of these. I'm going to choose the first one. 6 times 3 minus 4y minus 7 times negative 1 is equal to 17. I'm going to simplify here. We end up with 18 minus 4y plus 7 is equal to 17. We're going to isolate for this middle term by bringing this term and this term over. 17 minus 18 minus 7 minus 4y, and we end up with the following. 17 minus 18 minus 7 divided by negative 4y to isolate for that y, and we end up with 2. Therefore, the answer to this linear system of 3 variables is 3, 2, and negative 1. If you have any questions related to this, feel free to use our website at biology-forums.com. There is a part 2 to this video where I'll show you another linear system with 3 unknowns, but instead of using the addition-subtraction method, I'll use the substitution method instead. See you soon.